Hi everyone, we are starting. Oops. Yep. Okay. Before we are going to start with our speakers, just like a little bit of organizational keynote, just to start and give us a vibe. And we are starting to, we will give it in like Q&A format. So the first question that you will have, I think, it's where am I? React Barcelona, welcome. And we are going to be kind of monthly events now. We are going to try. So it will be monthly-ish events. Sometimes, yeah, we will be on schedule. Sometimes not. It depends on August. You know, August in Barcelona it could be hard. And also it depends, obviously, on speakers. But we're going to try to be monthly. What I'm doing here, not I'm, you're listening to great talks, obviously. So we'll have intro to React Virtualized by Eduardo and unit test in React and Redux by Dmitry. And the next question, why you are not in that list? Because, sorry, but we don't know about you. And you obviously need to apply for the next event. How to do that? It's going to Meetup.com React.js Barcelona and just writing there. Or go into GitHub Barcelona just React and creating an issue with your talk proposal. Or just tweet me, direct message me on Twitter or anywhere. Somebody said too. And we will discuss about it. So is any experience required to give a talk? No. Just really apply, send me a message, your idea or anything about your previous experience and your experience with React, and we're going to help you to create like talk out of it and format an idea and keynote and everything. Just really get in touch. So I'm going to finish talking already. Yes, enjoy the talks and thanks for coming.
So yeah.
Maybe source.
Somehow it's not detecting.
Hi everyone, we are studying. No?
Wait.
We are going to start with our yes.
Now? Yep. Okay. So let's move this here. Add. Yeah. Okay. So, hi everyone. I'm Eduardo Lanchares. Today I will talk you about what is React Virtualized. React Virtualized is a library that implements the virtual rendering technique. So today we will see what virtual rendering is, how it internally works, and how we can use it in our React projects to improve performance. So let's start. But first, I want to tell you a bit about a story about Redbooth Gantt. Everybody knows what a Gantt chart is? Yeah. Okay, so I'll skip the explanation. So this is the new Redbooth Gantt. This was a project that we started at the beginning of the year. And well, the main goal was to bring Gantt back to life to the Redbooth platform because some users were requesting it, and well, we think was a great opportunity. So we start implementing a Gantt prototype. We were picking all that features that we thought was more important for the MVP project. Sorry, for the minimal viable product. Well, we started implementing, we started building it, and we really got really good results with this. But we tried some demos and everything was working good. But we have one minor detail that was not MVP ready yet because we still need have it make it to production. So it was usable. Can you hear me? Everyone, can you hear me right? Yeah. Okay, I will continue. It's yeah, it's like it's homemade. So yeah, we had to make it to production because in order to move it to production, we need to test against real data, real projects that our users will be using. So for that, we created the 10-key project, a project with just 10,000 tasks. This was huge enough to stress our UI and see if our prototype could work with our user base. So yeah, we started testing it. We were gathering some results and metrics. Yeah, this is what we found. We detect that the initial rendering was a bit slow, the scrolling was really laggy, and the overall UX was not really good. So we started wondering why this was happening because we were using React and React is supposed to be ultra performant, so on. So yeah, we investigated, we used the React performance tools and see what was happening here. And we found these culprits. The first one, we were not using a proper implementation for should component update. So here, if you are using the default one, which is just re-render everything, as you may know, you're just wasting time not changing the DOM at all. So this was one of the culprits. We found and fixed it, and yeah, okay. We noticed a bit of improvement, but it was not fair enough. The second culprit was Redux. We were using Redux for manage our application state, and the thing is that we use it we were rendering too many components in the application, and every component was connected to the store. So that was causing performance issues because, for instance, when highlighting a Gantt row, this highlighting was really slow, really laggy, and that's because we weren't using a proper implementation for map state to props. So we found that, we fixed it, done. And the third culprit was the DOM. Again, we were rendering so many stuff that the scroll was ultra laggy, it was not usable at all, and that's because the browser was trying to lay out all those DOM and doing its job, but it hasn't time enough to complete in a decent amount of time. So here we have a situation. In one side, we needed to render all that node, so the user could scroll or go to the area of the chart they want. And on the other side was that we couldn't allow to render that amount of elements. So it was a problem. And we were questioning how we could display so large amount of data in a reasonable amount of time without freezing the UI and with crashing the browser. So here we start investigating what others were doing and how if there was a solution to this problem, and also checking on other platforms like mobile, because mobile platform had facing this a long time ago. Yeah, we found this virtual rendering. Yeah, virtual rendering is, if we can sum up in a higher concept, is just a matter of render only visible stuff. But in order to take a better perception of why this is so, the impact of using this, I want to show you an example. So this is an example of rendering 20,000 divs in a non-virtualized version, which is just a classic React example, versus the virtualized one. So here we can see that in the not virtualized example, the overall time of the rendering, of the initial rendering, was around 2 seconds. If we compare with the virtualized version, we see that was just 500 milliseconds, which is more or less 4 times faster. But the important thing I want you to notice here is this, where the time has been spent. So in the non-virtualized example, we can see that 700 milliseconds has been spent in rendering versus the virtualized version, which is only just 2 milliseconds. So what's going on? What's happening?
Sorry, what's scripting?
The scripting?
Yeah, scripting. This is the second part. What is that?
Yeah, I think it's the loading of all the examples and the libraries. Yeah, I will show you a real example, so we will see it. So in order to get more understanding of what's going on, I want you to show these real examples. So this is a non-virtualized, and I have the virtualized one. I want to first show you how is the scroll performing when we render, or we try to render 20,000 divs. So here we have the frame rate indicator, and I will start scrolling. Well, you can see it feels a bit laggy. Yeah, I stop scrolling. Well, I will do it again. Yeah. So here we can see that we barely hit the 22 frames per second, which is not really good user experience. If we compare with the virtualized version, we can see that we're hitting 60 frames per second. So we are beginning to understand the difference. But if you want to dig a bit deeper of what is happening here, I want to show you a small profile. So let me, this way. I will profile this example. I will scroll. Yeah, okay. Stop. So you can see here this great purple mountain, that what it's telling us is that the browser is spending most of the time just rendering things. It's using the layout phase of the rendering of a frame. So we can see here that the number of milliseconds we spent in the frame is really high. It's just marking as a long frame. But if we compare with the virtualized version, I will show you. I'll repeat the same example. Okay, scroll, yeah, enough. Okay, so we can see that, well, I can. Here, almost every frame is rendering in just 16 milliseconds, which is the recommended time to perform some rendering and to take and to hit the 60 frames per second ratio. So we can see here that, well, some time has been spent in JavaScript, but the important thing to notice here is that the update layer 3 was really low. It's not even a millisecond. So, continuing with the talk, this was just to take more understanding of what's happening under the hood. So if we go a bit deeper of how this virtual rendering technique works, we can just sum up into main parts. The first one is the windowing thing, which is just a matter of calculate which items are visible in the viewport, in the screen. So we can see that here we have 5 items, and only 3 and 4 are partially visible, and this is the area that will be our viewport. So this is just to give an idea of windowing. No, we're not going deeper on implementing this because it will be another talk itself. And the positioning one is just how we calculate and we will positioning that items in the scroll on the whole container. So this is an approach that React Virtualized takes. That is to create these outer and inner divs. The outer will be our viewport. The inner is just the container that will take the full width and height of our items. And what we're doing is wrapping each item we want to show into another div and positioning that absolutely. So here where we scroll the container, we are adjusting these coordinates and to mimic the same effect or behavior we have with a native scroll. So this is more or less what it works. So if you want to make it by yourself, I will recommend you not to do it because, yeah, in React, it's already done. This is the React Virtualized is the library we will see, and it's the one library that implements this technique. There are other ones, but I want to focus on this because this is actively maintained. You can use tabular and scattered layouts, and well, the important thing to notice here is that you use absolute positioning to perform all this positioning of items. So let's start seeing some components that this library provides. The first one is the grid, which is really good if we want some kind of, we have some tabular data, we want to create some spreadsheet, and you can see an example here. We can use dynamic row or dynamic width. You can see the columns are, every column is a different width. And well, if you're using things, implementing spreadsheets, things like that, it's the component to start with. The next one is the virtual scroll, which is just a list. It uses a grid and only use one column, so this is how it's implemented. And you can see that here the height of the row is also dynamic. And we can use, the library has support to implement infinite loading, like we can see on Twitter or Facebook websites. The next one is the flex table. This is similar to the grid, but this one implements a built-in header, and we can add things like sortable columns. So we can see that if we click on a column, we are ordering the items. So if we want this kind of behavior, this is a already built component, and also extends the grid. And the last one is the collection. This one, it's a component that allows us to lay out the components in whatever way we want. So for instance, in Redbooth GAN, we use this component to create the grid of the rows, dependencies, and columns that we use. So this is the component that is flexible, allows us to do these kind of things because we have items overlapping between each other, and with a tabular layout like the grid, it couldn't be possible. And one important thing to notice here is that at difference of differently of the grid, that it just use some improvements for the initial calculation of the cells. This one needs to first iterate over all your items just to grab the maximum width and the maximum height, so it can just detect all the items and how they are positioning. And this is some utility components this library provides. I will mention just a pair of that, which is the auto sizer, that is useful when we want our component to resize. Let's say we have a component and we want to expand to the whole window, and when we resize that window, we want our component to resize it too. So this is a component we will use. It's just a wrapper to our component, and it's done. We don't have to do anything special. The scroll sync is useful, and it's another we use in Redbooth, which is useful for synchronize this kind of components. So let's say we have, for instance, the header and the grid separate, and we want, as we scroll one, we want the header to scroll it too. So this is the component we will use. So let's see how complex or difficult it's migrating an example, a really naive example of a list built using React to the React virtualized version. So let's start with a collection of things we want to render. This is the items array. It's just an array of objects with a label property. And this is the naive React approach. So what we are doing here is taking those items, mapping that to this render function that what we'll do is just taking the item and extract the label and create a div component. Well, it's really self-explanatory. So if we want to migrate to React Virtualized, this same example, we will use a virtual scroll as we saw, that is just a simple list. And the main important properties we need to focus here is the width and height, which is the viewport of our component, the row height, which here I just use a static value, but we can use a function and just return different sizes depending on the item, where the index of the item, we'll see now. The row count that we are grabbing from the length of the items, and the row render, which is the same as the same function we were using in the map iterator we saw before. But the main thing to notice here is that instead of the plain object, or we are receiving an index, and for access to that item, we have to get these items array and get the item at that position. So because React Virtualized doesn't know nothing about our internal structure of our array, it just knows about indexes and how, and it's that what just provides. So in order to replicate the same behavior, we will need to use the index, extract the item, and well, it's repeating the same thing. So let's see now some real examples or other libraries and components that are using this library. The first one is the infinite calendar. It uses a virtual scroll component to render the months. It implements the infinite scrolling. So you can go to the months you want, just scrolling. And well, it has some smooth animations. Next one is a sortable list. It also uses virtual scroll. And the main thing to notice here is it integrates drag and drop support, and it's we can use it in touch devices. So we can use it on our mobile phones. And I recommend you to check this example because it's really smooth, the animations, even for a mobile web application. And the last one is Redbooth. This is the product that we released, and here is we are using a grid and a collection components. The grid we are using for this header for the months and the days, and the collection is used, as I already told, for rendering tasks and columns and dependencies. So we integrated drag and drop support too, and you can see that as we scroll, both grids and collection are synchronized. So now I want to show you some usage considerations that we have learned from our experience using this library. So the first one, data changes. This is important if you're going to use this library, to keep in mind that, as the documentation already states, virtual scroll has no way of knowing when its underlying list data has changed, since it only receives row height property. What this phrase is telling us is that if we're just passing the length of our collection, as we saw in the example, and we're just sorting the items, this component has no way of knowing that something has changed. If we want to manually trigger a rendering or a recalculation of all the sizes of our items, we'll need to use the recompute row heights. So this is just to keep in mind that we need to do that. The next topic is when we want to perform just a single cell update. So yeah, we can re-render everything, but what happens if we only want a specific cell to be updated? So we can see in the example that when we resolve a task, only this row is being updated. We are using a React plugin just to highlight the rendering area. And in order to fix this or to solve this, what we can use is to connect to a store like Redux, Flags, or Movex. So this component will be subscribed to change, and only that component will be updated. So that's the way we found it's the easiest way to use it with React Virtualized. And also, this is important too, that the state is not preserved in the component, because every time we scroll, the library will be calculating or recreating a new component every time. So if we set some internal state, we scroll to an area, we go back, the state is lost. So another interesting thing is the usage of a custom cell layout. Let's say we are somehow building a spreadsheet like project, and we want to render cells and put some overlay between them just to make them not clickable or whatever, or just a loading thing like in the image. So the examples we have seen so far just renders one cell. You have control to only one cell, but React Virtualized also supports the cell range render. So instead of just one cell, we are passing an array of indexes, of rows and columns, and it's up to us to lay out however we want. And the last thing is scroll flickering. So I don't know if we can appreciate in the image. Sometimes a yellow area will appear. Yeah, this scroll flickering is because in this example we're using the small cells, and React Virtualized doesn't have enough time to perform the rendering of the next row. So in order to overcome this, we can use the overscan option that will render the amount of cells we set ahead and will place in the top and the bottom, or if we are using a grid, at the both sides. The last section is just if you are interested in this library, just to getting started. These are the steps I recommend you to check. So go to the demo website. We have really nice demos, so you can check the performance or all the components that it can offer. Also clone the repo and check the example source code, which is really, really good. And if you have any doubt, you can chat with the author on Jitter, because he's a really helpful guy. Really, he really worries about all the community around the library. Well, that's all. Thank you. So questions? Yep.
Do you find that for a small amount of rendering, it's less performant than playing React?
Yeah, the question is that if I found that for a small amount of rendering on items, the performance is lower than the native or naive approach. I don't know the answer, but you just have to make some experiments and some profiling here. You will see. but maybe it doesn't just make sense. If you are not rendering a large amount of things, you are maybe that performance you're gaining, it's not, you're losing, I think. Yep.
And you mentioned 3 different things that affected the performance. I was wondering what the proportion of each one was in terms of the effect that it had. So you said about should component update and Redux being the other 2 things.
Yeah.
So what was the relative
So,
effect that each
so the performance we gain between each phase, I can tell you, I don't know the numbers.
Estimate, are we talking like?
Yeah, was like more perceived performance than the actual, but we really got some metrics I don't have yet. I can show you anything, but yeah, we.
Did it have the most significant effect?
Yeah.
Related to the previous question, so in our case, if it was necessary, if you want to render 10,000 tasks,
Yeah.
either you don't render all of them or it's going to be slow. Because if you're like 10,000 by very little, it's still a lot. So if you're optimizing for a worst case scenario, that where visualize is if you only expect, I don't know, 100 components to be rendered, maybe it's not needed.
Yeah.
Maybe the overhead is not that much, but in our case, it was because n was so large that that was the only way to actually make it useful.
Mm-hmm. Yeah. Any more? Yeah.
Do you really have problems in Redux? Do you have your sort of niche? Like, I mean, I know it's a big state, but did you notice?
Yeah. The thing with Redux was the implementation of map state to props. What's the main point? So we were just returning a plain object, and we found that we can use fabric functions. So the thing was that this was some kind memoizing the state. So we're not retriggering updates and calculating things. So that speed up a lot the highlighting process. Anyone? Questions? Ah.
Which is the best strategy to choose the overhead scan property? I mean, for
Yeah.
some computer could be 10,
Yeah.
And another one could be 100. You know,
Yeah.
It depends on the performance of each computer.
Yeah, I think that you will have to measure first. If you want to know the perfect number, you need to measure against different machines, different scenarios. But well, usually you don't need. By default, it's set to 10, and usually you don't see scroll flickering. But sometimes if you're trying to render in too much stuff and your render function takes a bit longer, you usually see that. And for the collection component, it's a bit even trickier because collection just what it does is just create sections of the grid. So you can set the size of that section. But if you set too much, when you scroll a bit, the library will just check all the items that are on that section, and even if you are not seeing that, it will render. So we are wasting time there. But it's something that you have to balance and to try it. Any more? Yeah.
Did you notice a more significant effect on different browsers? Is this something which is specific to rendering engines, or it just has a positive effect everywhere?
We found some issues in Firefox, but it was not because React virtualized itself, it was because of our implementation. But usually you can check the examples with different browsers, and you will see that it should behave more or less the same. Anyone? Any more?
And the second speaker, Dmitry.
Hi guys, my name is Dmitry. I'm working in Logify. Today I'm going to speak about unit testing in React and Redux. Can you please raise your hands who is doing unit testing in React and Redux, or just in React, whatever? Okay, like 50-50. Yeah, I will tell you story of our team. It's not like how you should do it, but maybe you can learn something. We have started a year ago with a good decision to rewrite the part of our application entirely by using new technologies and implementing it as a single-page application. It should be a new application, but there are a couple of requirements. The first thing, we have decided that we will not rewrite application entirely and we will not switch user directly, but we would like to embed the new application into old one, so user will still use the old one, and some pages we will be able to replace with the new, let's say, components inside. One of the requirements also was that this system needs to work good with a continuous integration and continuous deployment, because we have different environments and we want to be able to make something like feature toggling, etc. And new project should be long-term support, so it's not for one weekend. As a technology stack, we have decided to pick React and Redux plus ECMAScript 6, and for bundling we decided to choose a Webpack. And one of the key things was that we have decided to make tests from really beginning, like from the first day. And for the testing stack, we've decided to pick Mocha, Karma, and Expect, which is basically the default setup if you are starting to write on Webpack, React, and Redux. And in, I would say, a couple of days, we already have created the first test, and they was running. But then next commit, just break them. And we have realized that we have a problem. We have started to search the way how we can prevent one developer to build tests and second one to break them. The first idea was that we can run our tests on the CI, so when developer push the code, he will not be able to break anything. But unfortunately, it doesn't work. People still commit and break your environment and don't check it. And we've started thinking about any other solution, like, okay, we would like not to check after, but check before we are actually merging the code. And I think almost all the code stores, such as a GitHub or GitLab, they have things called pull request checks. Basically what it allows you to connect your continuous integration with the code storage and check certain checks, for example, running tests, and in general check that project is built for each pull request. Right now we are using this, and basically we have no problem with committing that code or merging that code. Well, except you are not admin and you're pressing this button at evening. Yeah, so we had the initial setup, but then we've noticed that no one actually wants to write tests. We have the test setup, we have 10 tests, and nobody writes single tests more. Yeah, we were thinking how to motivate each other in the team. And the first thing that we have tried to do is to search cool things about the testing, why we should write tests, how it can help us. We've started, and recently we've started finding new things which are really cool. First, that we have realized that we can actually ensure that code works as expected. Yeah, developers, when developers write code, they think that they know how it works and it works as expected, but not really. And it's much easier to ensure by writing tests. Another thing that we have noticed that while we are doing refactoring, it's much easier to keep code in the functional perspective like as it is, by running tests. So you can see that code is doing the same that it was doing before, even after refactoring. One of the key features also that we have noticed that we are not pushing dead code anymore. This is also good that tests are forced us to write better structured code, because it's really hard to test big functions and one file with 1,000 functions. So we've started to structure our code better, split into small parts which are easier to test. And also, unit tests help us a lot to understand code of each other just by reading tests, because you see the usage of the code, not the code itself. Even if it's complex things, you can get it easier. But the thing is that even after all of those motivation discussions, still nobody writes any single test. So is there any other way? And that was the thing that we've decided after another long meeting, that we will start to require each other to write tests for the new features and new code. And then we've got new question like, okay, should I test all my code that I'm trying to make a pull request? And after another discussion, we have created the list of things that we think that it's mandatory to test for our project. For us, we decided that it's mandatory to test reducers, action creators, components, business logic. And at the beginning, we decided that we shouldn't and we wouldn't test React, and I will explain later. For reducers, as far as you know, reducer, it's a function. It's a pure function which have 2 parameters as a state and action, and it returns new state. So the first thing that we decided to test is initial state, because you want your reducer to return the well-formed shaped state, and actually action handlers itself. It's super easy to test. Here's the example of test. Basically, we are forming the initial state, executing the reducer function, and asserting the returned value. It's easy because it's pure function, so it doesn't have any side effects or not changing world from outside. For actions, for us, we can differentiate the simple action creators, which are just functions which are returning new object and composing and returning, and asynchronous action creators. Those are functions which are asynchronously doing producing of new actions. For asynchronous action creators, we have decided to not to test the function calls, but instead test real functions inside the store. For this purpose, we've decided to use Redux mock store, which is like have the same API as Redux has, but much simpler and lighter, and it allows you to make tests easier. Yeah, and the last point that we decided to test was Redux connection components. Basically, we have decided to make it easier to test, to split map state to props and map dispatch to props to separate file, which we called mappings. It's much easier to test because those are also functions, and you can move them somewhere and test separately, aside from the smart component itself. But this is actually the old way, and the new fashioned way is to use selectors and test them. This is so new, so it was added like 2 weeks ago, I guess, by Dan Abramov, so we can just read the documentation. This way it's much easier because you're splitting your map state to props and map dispatch to props and moving them into different files, and it's much easier to test. Yeah, and one also important point is to test all the business logic. That was also the mandatory thing that we decided. If something is not in React or Redux, we need to test it, because most of the time it's also pure functions. If they are not pure functions, then especially we need to test them because they are changing the world from outside. and we need to ensure that they are working as we expect. Okay, so we start to write tests, but like they are mandatory on review, but it's better to write less tests just to pass review because you don't want to create a lot of code, etc. And we've started thinking how to make tests fun. The first thing that we have found, we have added the graph of the test execution, and then we've started to compete with each other by numbers, who's writing more tests, and that's really works because people are working like this. They like to compare numbers always. Another thing that worked, at certain point we had fixed code coverage. It's differentiate, but more or less it's stable. And we have decided that from this point we are requiring this amount of code coverage. So as soon as you're writing new code, you should cover it with the same percentage. And it's not that easy to cheat in these kind of things. So we've started to write tests, but immediately we've got a lot of questions. We don't know how to write tests. And we decided to create a unit testing manual. Basically, it's a wiki page where we are trying to describe all the naming conventions, structure of our tests, how to write tests properly, where to place them. We have tried to show examples of testing of each part for reducers, for basic action creators. And the best part is FAQ. As soon as you have a question, you are adding this question there. And when you are you found the answer, you are just putting answer there. So next person will just read it here and will not spend time on this. So yeah, we are writing tests for each pull request, and it's cool. But we have found that test execution is really slow, especially locally. When you start to run tests, it needs to create a build, it needs to create a bundle. And for us, bundle was super slow. It took about 3 minutes just to build and run tests, the initial build. And we've started to search, is there any way to minimize the time of the execution? And we have found that the weak point is resource processing. So basically, the hardest part for Webpack is when you are using CSS imports or less, or SAS imports. It needs to pre-process it, and then build the bundle for styles. And we have realized that we don't need any CSS or images or anything else, any kind of resources except JavaScript in our testing bundles. So we have created a separate Webpack config for tests, which we are running, this build we are running localhost, which is surprisingly twice faster. Yeah, we was writing tests, but we really want to do it easier. We have found that testing things like Redux, it's really duplicating code. So what we decided to do is we moved similar parts to things that we call base tests. It's basically a number of tests which are parameterized, and you are able to generate tests by running this function and passing your reducer. That's how we are generating basic tests for all our reducers, for all our simple action creators. And yeah, we're just trying to create more things to make it easier to test for us. That's cool. We are writing tests for for Redux. We are covering all of the business logic, but what about React? From the first day, we've honestly tried to test React, but for those of you who know how to test React, who was trying to test it with the utilities from the React library itself, it's just nightmare, because the amount of code that you are producing just to prepare the component, to render it, and to test it is like twice bigger than the component itself. And we've started to search any kind of utility to simplify our life. And fortunately, week before we start, Enzyme was released by guys from Airbnb. This library, I guess, it's right now like official utility functions for testing React, and it's super easy. We've set it up in like a couple of minutes, and we have written first test. It's much easier to write tests. It's way cleaner. But then we had another problem that we've started refactoring and reorganizing our code. At a certain point, we have realized that we had problems in our component organization, and we've started to move to split components from 1 to 2, then merge some components, make one of them smart, another is dump. That's why we decided to stop at that point to write any test. And finally, about a month ago, we have finally stabilized our structure, our code structure, our component structure, and we've decided to start writing tests again. As soon as we start, we've got a question. Okay, should we test all the components that we have, like all 200 components? And honestly, no, because basically you need to check if component is contain any business logic, then you should test it. If it's a simple functional component, then probably you shouldn't test it because you will just duplicate your code. By writing component and writing test, it will look the same, so there is no reason. And another question was, okay, component is pretty big. Should I test the whole component from beginning to the end? And here are things that we have decided to test.